Now questions, find the values. Sine inverse minus half. See, whenever a negative number is given, then first of all, using properties of inverse trigonometric function, we shall take that negative sign outside. We know that sine inverse minus x is minus sine inverse x. So minus is taken out by property. See, tan inverse minus x. Tan inverse minus x is minus tan inverse x. Cosec inverse minus x is minus cosec inverse x. Sine inverse, tan inverse and cosec inverse, when inner number is negative, it comes out. Cos inverse, here cos inverse is working on negative. Cos inverse minus x is not minus cos inverse x, but cos inverse minus x is pi minus cos inverse x. If a sec inverse is given, then also sec inverse minus x is pi minus sec inverse x. If cot inverse is given, then also we do same. Cot inverse minus x is pi minus cot inverse x. Then minus sine inverse. Now 1 by 2. See, outer function is sine inverse. So 1 by 2, put value in terms of sine. So 1 by 2 is sine pi by 6. 1 by 2 we replace by sine pi by 6. Here minus cosec inverse, now root 2. Root 2 is value of cosec pi by 4. Outer is cosec inverse, so set inner cosec. Outer is tan inverse. So express root 3 as tan of pi by 3, because root 3 is tan pi by 3. Here it is root 3 by 2. Cos inverse. Root 3 by 2 is cos pi by 6. Here outer is cos inverse. See, everywhere first of all we have converted this negative number into positive. Negative into positive. Negative into positive. Here already positive given. Negative into positive. And after getting positive, you know values. 1 by 2 is value of cos pi by 3. So doing this procedure, now it is sine inverse sine theta. Now sine inverse sine theta, sine inverse sine theta is theta. If theta belongs to close interval minus pi by 2 to pi by 2. And say here it is pi by 6. So sine inverse sine pi by 6 is pi by 6, because pi by 6 belongs to this interval. So its value is minus as it is, and by rule pi by 6. This is equal to minus. Now cosec inverse. Cosec inverse cosec theta equal to theta if theta belongs to close interval minus pi by 2 to pi by 2 except 0. And look here, already we set a number belonging to that domain of cosec, pi by 4. Cosec inverse cosec pi by 4 is pi by 4, because pi by 4 is in this domain of cosec. So this is equal to pi by 4 minus, as it is, tan inverse tan theta. Tan inverse tan theta equal to theta if theta belongs to open interval minus pi by 2 to pi by 2. Tan inverse tan theta, here number is pi by 3. So tan inverse tan pi by 3 is pi by 3 because pi by 3 is in minus pi by 2 to pi by 2. So this is equal to pi by 3. Cos inverse cos theta is theta if theta belongs to close interval 0 to pi. So very important properties during the whole chapter. In almost many questions we shall use these properties. Cos inverse cos theta, cos inverse cos pi by 3 is pi by 3 because pi by 3 is in that interval. So pi minus pi by 3, so this is 2 pi by 3. Here cos inverse cos pi by 6, again by same rule it is pi by 6. Now say here, first of all we use here a property to remove this minus sign which is inside. This number tan inverse 1 just we keep as it is, plus cos inverse minus x, it is pi minus cos inverse x. Cos inverse minus half is pi minus cos inverse half. As see, just here we have done same procedure, it will be followed here. Sin inverse minus half, sin inverse minus half is minus sin inverse half. So this is now tan inverse 1. So tan inverse 1 is tan pi by 4, pi as it is, cos inverse half is cos pi by 3 here discussed, minus sin inverse half is sin pi by 6. Outer is sin inverse, set inner sin. Outer is cos inverse, set inside cos. So this is equal to pi by 4 plus pi minus, this will be pi by 3 minus pi by 6. So this is LCM is 12. So this is 3 pi plus 12 pi minus 4 pi minus 2 pi. So 12 plus 3 15, 15 minus 6 9, 9 pi by 12. So 3 pi by 4. So that is required value. Now see, this question can also be solved by another method. Same question, tan inverse 1 plus cos inverse minus half plus sin inverse minus half. Look this part, see these numbers are same, minus half minus half. Now we know property that cos inverse x plus sin inverse x is pi by 2 if x belongs to minus 1 to 1. If these numbers are same belonging to this interval, then its value is pi by 2. And here it is minus half. Minus half is in this interval. Both numbers are same. So by this property, its value is pi by 2. And tan inverse 1. Tan inverse 1 is, it will be pi by 4. 1 is tan pi by 4. And this is pi by 2. Reason is inside. This is pi by 4 plus pi by 2. So that is equal to here pi plus 2 pi by 4. So this is 3 pi by 4. So you can also do by this method. See, when doing multiple choice questions, short questions, after this step, directly you can put this step. Sine inverse half is pi by 6, because sine pi by 6 is half, so sine inverse half is pi by 6. After this step, you can also put direct this step, because cosec pi by 4 is root 2. Cosec pi by 4 is root 2, so cosec inverse root 2 is pi by 4. You can remember by this way, if the numbers are positive, because for positive numbers you know value very well without any mistake. From this number you can put direct this step, tan inverse root 3. Tan pi by 3 is root 3, so tan inverse root 3 is pi by 3. So tan inverse root 3 is pi by 3. Cos inverse root 3 by 2 is pi by 6. Here cos inverse half is pi by 3, because cos pi by 3 is half, so cos inverse half is pi by 3. So this can be done in short way also by putting directly value if you don't allow any mistake. Now to find these values, sine inverse sine 2 pi by 3. Say sine inverse sine 2 pi by 3, if I keep here 2 pi by 3, then this is not correct. It is not like that sine inverse sine is cancelled. But see, what is rule? Sine inverse sine theta is theta if this number belongs to minus pi by 2 to pi by 2. It must be belonging to this close interval minus pi by 2 to pi by 2. But here this number is more than pi by 2. 2 pi by 3. 2 pi by 3 is somewhere here. And according to requirement, theta should be in this interval minus pi by 2 to pi by 2. If theta is in minus pi by 2 to pi by 2, then sine inverse sine theta is theta, but because the number is not in domain of sine, its value 2 pi by 3 is not the correct answer. So what we do? We convert this number into a new number belonging to this interval. So we can use this rule, for which we use a property of trigonometric function. 2 pi by 3 can be expressed as pi minus pi by 3. 2 pi by 3 is pi minus pi by 3. So now it is sine inverse. Now sine pi minus theta. Sine pi minus theta, second quadrant. In second quadrant sine is positive. So sine pi minus theta is sine theta. Now look this new number. It belongs to required interval. So sine inverse sine pi by 3 is pi by 3. In this question, tan inverse tan 3 pi by 4. Tan inverse tan 3 pi by 4 equal to 3 pi by 4 if 3 pi by 4 belongs to open interval minus pi by 2 to pi by 2. But here 3 pi by 4 is somewhere here, which does not belong to open interval minus pi by 2 to this is open interval. So its value is not equal to 3 pi by 4. This is not correct answer. So to obtain its proper value, what we do? Given number which does not belong to this interval, we convert it into a new number belonging to that interval. So using property of trigonometric function, this 3 pi by 4 can be expressed as This can be expressed as pi minus pi by 4. So then this will be tan pi minus theta, second quadrant. In second quadrant tan is negative. So tan pi minus theta is minus tan theta. Now tan inverse minus x. Tan inverse minus x is minus tan inverse x. Tan inverse minus x is minus tan inverse x. And now look this new number. It belongs to domain of tan. So this is equal to, its value is pi by 4. So minus of pi by 4, this is final value. Say here 13 pi by 6. Cos inverse cos 13 pi by 6 equal to 13 pi by 6 if 13 pi by 6 belongs to 0 to pi. In case of a cosine function, theta should be in first half upper rotation, 0 to pi. But here 13 pi by 6 is more than 2 pi. It comes after first complete rotation. It is more than pi. So cos inverse cos 13 pi by 6 equal to 13 pi by 6 is not true. So to convert this into a new number using the property of trigo, 13 pi by 6 is more than 2 pi. So 2 pi plus pi by 6. Now it is 13 pi by 6. Then cos inverse cos 2 pi plus theta. Cos 2 pi plus theta, first quadrant, cos is positive. So it is cos pi by 6. Now cos inverse cos pi by 6 is pi by 6. Because pi by 6 is in 0 to pi. Pi by 6 is at here. So it is equal to pi by 6. In this question, cos of pi by 3, say minus as it is, sine inverse of negative. Sine inverse of minus x is minus comes out. So minus minus plus. Sine inverse half. Now cos of pi by 3 plus sine inverse half is pi by 6, because sine pi by 6 is half. Or you can show in detail that pi by 3 sine inverse 1 by 2 replaced by sine pi by 6, and then in the next step value is pi by 6. So this is cos of pi by 2. Pi by 3 plus pi by 6 is pi by 2, and cos pi by 2 is 0. So its value is 0. Now in this question, tan of 1 by 2 into, now look this term, we are having formula. We know that 2 times tan inverse x equal to sine inverse 2x upon 1 plus x square. We are already having this result. If modulus x is less than 1. So because we are having this result, now we shall use this result. So this will be replaced by here 2 times tan inverse x. We have one more result, that is 2 times tan inverse x equal to cos inverse 1 minus x square upon 1 plus x square if x is more than 0. That is another result. And applying this result here, so here y is given. So if here y is given, see y square, put here y, replace x by y. So in formula x is replaced by y. So this is 2 times tan inverse y. So this is the reason for this step. Now multiplying this 1 by 2 inside, tan of 1 by 2 into this number is tan inverse x plus 1 by 2 into this number is tan inverse y. Now tan of, now here inside we are applying formula tan inverse x plus tan inverse y. We have one more result, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus xy if xy is less than 1. If xy is less than 1, then we can replace the sum of numbers by this term and say this is also given. Condition, required condition is given to apply this formula. So because xy is less than 1, this is equal to, by this formula, tan inverse x plus y upon 1 minus xy. So for this step, this formula is used. Now we have one more result, that tan of tan inverse x equal to x for every x belonging to R. For every x belonging to R, tan of tan inverse x is x. Domain of tan inverse is R. So say here, this is any real. It must be defined. If xy equal to 1, then denominator will be 0. But here xy is not equal to 1, xy is less than 1. So because xy is less than 1, this denominator is non-zero. So whatever will be its value, it is defined real number. May be positive, it may be negative. It is defined real number. And tan of tan inverse any real, that is by this rule, tan of tan inverse any real, so real remains unchanged. So this is x plus y by 1 minus xy. So here for this step, this is used. So this is required value. To find the value of this expression, tan of this number, we suppose this is x and this value is y. Let sine inverse 3 by 5 is x and cot inverse 3 by 2 is y. Sine inverse 3 by 5 we are supposing x, this we are supposing y. So required value will be, see, so required value will be tan of x plus y. X plus y. This part we have supposed x and this part we have supposed y. So what we want? Tan of x plus y. Now tan of x plus y is tan x plus tan y upon 1 minus tan x into tan y. So to find this value, we want value of tan x and tan y. Say here, Sine inverse 3 by 5 is x. From this we want tan x, and from this value of y we want tan y. So what we do? From this expression, sine inverse 3 by 5 is x, so sine x is 3 by 5. That means sine x is 3 by 5, and cot y will be equal to 3 by 2. So sine x is obtained, cot y is obtained. Now look, here x is output when sine inverse works on positive. So value of x, we are checking whether value of x, it lies in which interval, it belongs to which interval, and value of y belongs to which interval, that we are checking. See, explaining here, sine inverse, its domain is -1 to 1 and codomain is -π/2 to π/2. -1 to 1, that is, imagine two parts of this interval. This part contains positive numbers, this part contains negative number. Here imagine two parts. This part is containing negative numbers, this part is containing positive numbers. When sine inverse works on numbers belonging to this interval, outputs lie in this interval. So when sine inverse works on a number, if number is a positive, if x is in this interval, then output will be in this interval. Here there will be value of sine inverse of positive. If this number is positive, say here 3 by 5, 3 by 5 is positive. So when sine inverse works on 3 by 5, so sine inverse 3 by 5 belongs to positive. So it is clear that this covers first quadrant. In first quadrant, sine is positive. So sine inverse of a positive is positive. Sine inverse of positive is positive. In fourth quadrant, sine is negative. In fourth quadrant, this covers fourth quadrant. Sine is negative. That means sine inverse of negative, it will be in this interval. But here 3 by 5 is positive. So sine inverse 3 by 5, it will be in 0 to π/2. So sine inverse 3 by 5, its value is x. For this number we have supposed x. So x belongs to 0 to π/2. So x belongs to 0 to π/2. Now we talk about cot. Here value of cot y is 3/2. Cot inverse. See, cot inverse, its domain is R. Codomain is open interval 0 to pi. R contains all positive, all negative. Here 0 to pi. Here 0, pi. Here π/2. See, cot is a positive in first quadrant. Here cot is positive. So cot inverse of positive, it lies in this interval. Here cot inverse of positive, 3/2 is positive, 3/2 is somewhere here. So cot inverse of 3 by 2, it will be in 0 to pi by 2. So cot inverse of 3 by 2 is y. So y will be in 0 to pi by 2. So y is open interval 0 to pi by 2. Here this value is neither 0 nor 1. So value of x, it will not be 0, it will not be pi by 2. So here also we can put open interval. If a sine inverse, here the number is 1, sine inverse 1 is pi by 2, but this 1 is not given, so this is not pi by 2. Sine inverse 0 is 0, but here 0 is not given, so x is not 0, so I have excluded 0 and pi by 2. So in this case, x and y both we can show a condition combinedly, both are in 0 to pi by 2. So always remember, whenever sine inverse works on positive number, output is positive, means first quadrant. Cot inverse of positive, it lies in first quadrant. Cot inverse, tan inverse, sec inverse, take any inverse trigonometric function. Cos inverse of positive, sec inverse of positive, tan inverse of positive. So inverse of any positive, it will be always in first quadrant, because every this inverse trigonometric function, it's a codomain, contains part of first quadrant. So that's why 0 to pi by 2. Now we want tan x, here it is sin x. So from sin x, cos x can be found. Cos x is square root of 1 minus sin square x, that is 9 by 25. So this is 25 minus 9, 16 by 25, so 4 by 5. We take a positive square root because x is in first quadrant. So sin x is found, cos x is found. Therefore, tan x is equal to sin x upon cos x. So it is 3 by 4. We obtain value to put here. Tan x is 3 by 4. And from this number cot y, tan y is, cot y is 3 by 2, so tan y is its reciprocal 2 by 3. So putting these values here, tan x is 3 by 4, tan y is 2 by 3, 1 minus 3 by 4 into 2 by 3. So this is equal to, LCM is 12, here 9 plus 8, here 12 minus 6 upon 12, 12 cancel, 17 upon, this is 12 minus 6, that is 6. So value is 17 upon 6. So this is required value. Now here in this question, left hand side, we prove, we are beginning from left hand side. Left hand side is 2 times tan inverse half plus tan inverse 1 by 7. 2 times tan inverse half can be written as tan inverse half plus tan inverse half. 2y is y plus y. This number as it is. Now here, matching this with a tan inverse x plus tan inverse y, we are applying formula tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy if xy is less than 1. So check product x, y. Product is 1 by 4 less than 1. So it is equal to tan inverse by this formula x plus y upon 1 minus x into y. So product is 1 by 4 plus tan inverse 1 by 7 as it is. That is equal to tan inverse, this is 1 by 2 plus 1 by 2 is 1 upon 4 minus 1 3 by 4 plus tan inverse 1 by 7. So this is tan inverse 4 by 3 plus tan inverse 1 by 7. Now again we can match with this formula. So check product. Product of these numbers is 4 by 21. It is less than 1. So this is equal to, by this formula, tan inverse x plus y upon 1 minus x into y, 4 by 21. So this is equal to tan inverse 7 into 4, 28 plus 3 upon LCM 21 upon 21 minus 4 upon 21. This is cancelled. So tan inverse 31 upon 17 and it is required RHS. This is RHS. So result is proved. LHS is equal to RHS. Now to prove this question, beginning from left hand side is tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. There are 4 numbers. We make pair of two numbers. Pair of two numbers. There are 2 pair of 2 numbers. Now look here. Tan inverse x plus tan inverse y. Formula is applicable. Check product. Product of these 2 numbers is 1 by 35. It is less than 1. So by formula, tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus x into y, that is 1 upon 35. Similarly, here product of these 2 numbers is 1 by 24. It is also less than 1. So applying same formula, tan inverse x plus y upon 1 minus x into y. Simplifying this, tan inverse, this will be 7 plus 5, 12 by 35 upon 34 by 35 plus tan inverse, here 8 plus 3, 11 by 24 upon 23 by 24. So this 35, 35, 24, 24 is cancelled. This is equal to tan inverse 12 by 34 plus tan inverse 11 by 23. Here tan inverse 12 by 34, this is 6 into 2, 17 into 2. So tan inverse 6 by 17 plus tan inverse 11 by 23. Now once again, tan inverse x plus tan inverse y. Check product. Product is 66 upon 23 into 17, obviously product will be less than 1. So applying formula, it is equal to tan inverse x plus y upon 1 minus x into y, that is equal to tan inverse. Now here 23 into 6, taking LCM, see LCM is 17 into 23, this is LCM. In denominator also LCM is 17 into 23. 23 into 6, 138 plus 17 into 11, 187. Here 23 into 17, it will be multiplied with 1. 23 into 17, that is here 23. This is 161. So 391. So 391 minus 66. So this is, it's a simple form. So it is equal to, this is equal to, so simplifying inner number we are getting here, this is equal to tan inverse, see 8 plus 7 15, see this is cancelled, 1 3 plus 1 4, 4 plus 8 2, 325 upon 391 minus 66, it is 325. So this is tan inverse 1, and tan inverse 1 is equal to pi by 4, and pi by 4 is RHS. So LHS is equal to RHS. Therefore LHS equal to RHS. Now in this question, left hand side is in terms of sine inverse, RHS is in terms of tan inverse. So what we are doing, this number we are going to convert in a tan inverse, means sine inverse 3 by 5 is equal to how much tan inverse of something. Sine inverse 3 by 5 equal to tan inverse of how much? That is the question. So in short, we want to convert this into tan inverse. Because RHS is tan inverse, we suppose sine inverse 3 by 5. Suppose that sine inverse 3 by 5 is x. Here suppose that sine inverse 3 by 5 equal to x. Therefore sine x equal to 3 by 5, and because this is positive, sine inverse of a positive, it belongs to, output belongs to first quadrant, where x belongs to first quadrant 0 to pi by 2. Sin x is 3 by 5, so cos x is square root of 1 minus 9 by 25. This will be positive because x is in first quadrant. So cos x is equal to 25 minus 9, 16, 16 upon 25, its square root is 4 by 5. Sin x is 3 by 5, cos x is 4 by 5, so tan x is 3 by 5 upon 4 by 5, that is 3 by 4. Tan x is 3 by 4, therefore x is tan inverse 3 by 4. Tan x is 3 by 4, then x is tan inverse 3 by 4 by property. 10 can be shifted on this number because x is in domain of 10. X is in domain of 10, therefore 10 can be shifted on that number. Because reason for shifting this 10 on this side is x belongs to 0 to pi by 2, so this was allowed. Now LHS is 2 times sine inverse 3 by 5. 2 times sine inverse 3 by 5 is x. This we have taken x. And now sine inverse 3 by 5 is x and x is tan inverse 3 by 4. So now this x I replace by tan inverse. So what we have done, sine inverse is converted into tan inverse. And because here multiple is 2, this can be expressed as tan inverse 3 by 4 plus tan inverse 3 by 4. Now formula, product of these two numbers is less than 1. So tan inverse x plus tan inverse y is tan inverse x plus y upon 1 minus product of these two numbers 9 by 16. So this is equal to tan inverse, this will be 3 by 4 plus 3 by 4, that is 6 by 4. 6 by 4 is 3 by 2 upon 16 minus 9, 7 by 16. So this is equal to tan inverse 3 by 2, here 7 over 16, 2 into 8, 16. So it is tan inverse 24 by 7, which is RHS. This is equal to RHS. So LHS is equal to RHS. Now in this question, RHS is tan inverse. So again we are going to convert these both numbers into tan inverse by similar procedure. Because here there are two distinct numbers, for this number we are supposing x as did here, and for the second number we suppose y. So let sine inverse 8 by 17 is x and sine inverse 3 by 5 is y. Because these are positive and belonging to minus 1 to 1, so sin x is, therefore sin x is 8 by 17 and sin y is 3 by 5, and both x and y will be in first quadrant 0 to pi by 2. Because sin inverse is working on positive, when sin inverse works on positive, output is in 0 to pi by 2. Now sin is obtained, so cos x is positive square root of 1 minus sin square x, that is 64 upon 289. It is equal to square root of 289 minus 64 is 225. 225 by 289, that is 15 by 17. This will be cos x. From sin y we also find cos y and cos y. Cos y is positive square root of 1 minus sin square y, that is 9 by 25. So this is 16 by 25, so 4 by 5. So this is cos y. So from sin x, cos x is obtained, therefore tan x equal to 8 by 17 upon 15 by 17. So it will be 8 by 15. And say putting here in detail, tan x is sin x upon cos x. So this is 8 by 15. Tan x is 8 by 15, and from these values sin y and cos y, tan y is sin y upon cos y, 3 by 4. So tan x is 8 by 15 and tan y is 3 by 4. So x equal to tan inverse 8 by 15 and y equal to tan inverse 3 by 4. So see what is done here. X was for sin inverse 8 by 17 and now x is also tan inverse 8 by 15. So what is proved? Sin inverse 8 by 17 is converted into tan inverse. Similarly, this value is converted, sin inverse 3 by 5 is tan inverse 3 by 4. So both numbers which are on left side are converted into tan inverse. So LHS is, now LHS is sin inverse 8 by 17 plus sin inverse 3 by 5. Sin inverse 8 by 17 is, that was for x, this is for y. X is tan inverse 8 by 15. Y is tan inverse 3 by 4. Now product of these numbers is less than 1. So applying formula, tan inverse x plus y upon 1 minus x into y, so 24 by 60. So that is tan inverse, this will be 32 plus 45 upon 60, and here 60 minus 24 upon 60. So this is tan inverse 77 upon 36. It is RHS. So LHS is equal to RHS. See, right hand side was in terms of tan inverse. So that's why these numbers are converted into tan inverse. Now same question by method 2. Till this steps are same. After this step there is change, variation in method. See, the variation is, after getting value of tan x and tan y, here these are x and y that in the beginning we have taken. So what is here? X plus y equal to tan inverse something, that we want to prove. X plus y equal to tan inverse something. So to prove that x plus y equal to tan inverse something, tan inverse shift on this side. So when over x plus y you take tan inverse on this side, term will be tan of x plus y. So we will show that tan of x plus y is 77 by 36. So beginning from that planning, tan of x plus y we are going to show 77 by 36. So formula for tan of x plus y is tan x plus tan y upon 1 minus tan x into tan y. Putting value, tan x is 8 by 15, Tan y is 3 by 4. 1 minus 8 by 15, 3 by 4. That is, this is 32 plus 45 upon 60 minus 24, 77 by 36. So tan of x plus y is 77 by 36. Therefore, now take tan on this side. So x plus y is tan inverse 77 by 36. And what is x? X is sine inverse 8 by 17. What is y? Y is sine inverse 3 by 5. So this is equal to tan inverse 77 by 36. So LHS is equal to RHS. So here RHS we want in terms of a sine inverse. So method is, first of all, we suppose this number is x, this number is y. So let cos inverse 12 by 13 is x and sine inverse 3 by 5 y. Now see how to determine method, that what to do, which formula will be used, which values are required. See, the procedure is, we want to prove that LHS equal to RHS. So we want to prove that cos inverse 12 by 13 plus sine inverse 3 by 5 equal to sine inverse 56 by 65. To prove LHS equal to RHS, we have to prove this statement. That is, we have to show that, see, for first number we have taken x, for second number we have taken y, equal to sine inverse 56 by 65. So to prove this statement, we have to show that x plus y equal to sine inverse 56 by 65. To prove this statement, we shall prove that, see, now think sine inverse, shift sine inverse on this side. So sine of x plus y is 56 by 65. So to prove this statement, we have to prove this statement. Then after getting this statement, shift sign on that side. So then it will be done. So that means now question is, now in this question we want to prove value of sine of x plus y equal to 56 by 65. That is the question. Prove that sine of x plus y is 56 by 65. Now to get value of sine of x plus y, formula is sine x cos y plus cos x sine y. We require 4 values. So which values are given? Here cos inverse 12 by 13 is x, therefore cos x is 12 by 30, and from this statement sin y is 3 by 5, cos x is 12 by 13, sin y is 3 by 5. These values are given, so we require now these values. Because cos inverse is working on positive, sin inverse is also working on positive, so therefore x and y both numbers will be in 0 to pi by 2. So alternate values, from cos sin will also be positive and cos will also, from sin y cos y will also be positive. Now sin x is square root of 1 minus cos square x, that is 144 upon 169. So this is square root of 169 by 144, that is 25 by 169, 5 by 13. So sin x is 5 by 13. Cos y is 1 minus sin square y, so 9 by 25. So this is square root of 16 by 25. So this is 4 by 5. So put here 4 by 5. So this is 20 plus 36 by 65. So it is proved. Sin of x plus y is 56 by 65. Sin take on this side, put value of x and y. So result is proved. Suppose in this question, if you are given here cos inverse, if you want here cos inverse, then you need to prove cos of x plus y. So you have to find value of cos of x plus y. So which formula should be used? Hint can be obtained from this RHS. If here tan inverse is given, in last question, see second method, it was tan inverse. So we found tan of x plus y. So this is the procedure.